The domino effect of poor quality information. In asset-intensive industries, safety and regulatory compliance are non-negotiable, and the quality of your data is a strategic differentiator. At ReVisionz, we specialize in helping companies unlock the full potential of their physical assets through intelligent data strategies, digital transformation, and asset information management, AIM. We've seen firsthand how inaccurate, inconsistent, or outdated data can ripple across engineering and operations by creating avoidable process risk, inflating costs, and eroding trust in systems and processes. The reality of these circumstances is outlined in the video below. This article explores both the negative and positive domino effects of data quality, drawing on industry examples and insights from our work with clients. It also provides guidance on how to reverse the cascade of inefficiency while building a resilient and insight-driven data environment. The negative domino effect. When data fails you. Poor quality, incomplete, duplicate, inaccurate, or inconsistent, data can set off a chain reaction of detrimental events while severely impacting safety and costs in engineering, operations, and maintenance. According to industry research, it costs the global oil and gas sector alone over $30 billion annually, primarily due to rework, delays, and safety incidents. These cascading failures are preventable, but only if organizations treat data quality as a priority rather than an afterthought. Safety implications. When data is outdated, for example, out-of-date P and IDs, new or evolving, hazards may go unrecognized. Imagine an oil refinery where a high-pressure distillation column is designed with a relief valve to prevent overpressure situations. However, if the P and ID erroneously omits the relief valve or misidentifies it as a manual vent, safety engineers conducting a hazard identification might assume the system has adequate overpressure protection when, in reality, it does not. This mistake could lead to failure to assess overpressure risks, as the hazard study may not identify the missing relief system. Incorrect safeguard recommendations, such as suggesting operating procedures instead of the critical installation of a relief valve. Potential catastrophic failure, where an overpressure event could result in vessel rupture, fire, or even explosion due to hazard identification based on flawed documentation. Flawed risk assessments, since these depend on accurate data to evaluate the likelihood and impact of hazards. More than 70% of process safety incidents are linked to information gaps or miscommunication. Ineffective emergency response plans, which may rely on outdated information that no longer reflects current operations or infrastructure, leading to delays and poor incident response. Hidden cost drivers. Relying on outdated data can cause suboptimal decision-making and process inefficiencies. An example of how outdated data can lead to operational failures is using the wrong bearing in a centrifugal compressor due to an inaccurate parts database. Imagine a petrochemical plant relying on a high-speed centrifugal compressor to maintain critical gas processing operations. The Asset Master data incorrectly lists the required bearing specification as a standard grade bearing, when in reality, the compressor requires a high-performance, low-friction bearing designed to withstand extreme rotational speeds and temperature conditions. The consequences of this incorrect part installation could include premature failure and downtime. Incorrect parts or poor asset data can cause early equipment failure, leading to excessive vibration, unplanned shutdowns, and frequent reactive maintenance. These interruptions drive up replacement costs and reduce production uptime. Reduced efficiency. The compressor delivers lower throughput while consuming more energy, resulting in higher utility bills and diminished operational performance. Increased maintenance costs. When asset data is inaccurate, maintenance plans become inefficient. If maintenance is scheduled too frequently, it drives up costs. If it's too infrequent, it can lead to unexpected failures. This disrupts production, increases labor hours, and raises overall expenses. Reactive maintenance is estimated to cost 2 to 5 times more than planned maintenance. Project delays. Outdated data can cause rework and project delays. Engineers might need to revise designs or wait for updated information, extending project timelines and inflating labor costs. Construction projects experience an average of 10 to 15% cost overruns due to data issues. Regulatory penalties. Adherence to safety and environmental regulations is crucial. Outdated data can result in non-compliance, attracting fines, legal penalties, and damage to an organization's reputation. Real-world example. The 2010 Deepwater Horizon disaster is a powerful example of how poor quality data can trigger catastrophic consequences. Investigations found that reliance on inaccurate data and misinterpretation of pressure readings caused missed warning signs and poor decisions. According to a 2011 report, the result was a blowout that claimed 11 lives, caused massive environmental damage, and cost BP over $65 billion in penalties, cleanup, and legal fees. The incident highlights how data failures can escalate quickly into operational, financial, and reputational crises, especially in high-risk industries. The positive domino effect when data enables success. While poor data creates friction and risk, high-quality and well-managed data does the opposite. Organizations that invest in improving data quality quickly see those efforts compound. Even small improvements unlock a cascade of positive outcomes, from reduced downtime and improved compliance to stronger financial results and better strategic alignment. Enhanced safety outcomes. Improved data quality strengthens every layer of operational safety, resulting in the following safety outcomes. Accurate hazard. Identification. Current data allows for the precise identification and mitigation of potential hazards. This reduces the likelihood of accidents and improves workplace safety. Effective risk assessment. Up-to-date data supports accurate risk assessments while enabling better-informed decisions and the implementation of effective safety measures. Optimized emergency response. Accurate data allows for the development of effective emergency response plans that are tailored to current conditions, ensuring swift and effective action during incidents. Measurable cost savings. Well-managed data helps organizations operate more efficiently and lead to long-term savings across the business in areas such as increased operational efficiency. With accurate data, operations can be optimized for maximum efficiency. For example, production processes can be fine-tuned to meet current demand while reducing waste and lowering costs. Optimized maintenance. Data-driven maintenance schedules ensure that equipment is serviced at optimal intervals. This prevents unexpected failures and extends the lifespan of assets. Predictive maintenance can reduce maintenance-related costs, such as unplanned repair expenses and emergency labor costs by up to 40% and downtime by up to 50%. Timely project completion. Accurate information facilitates precise planning and execution of projects, reducing the likelihood of delays and keeping labor costs in check. Regulatory compliance. Up-to-date data enables compliance with safety and environmental regulations, so organizations can avoid costly fines while improving their reputation. Real-world example. A strong example of the positive impact of high-quality data is General Electric's use of predictive analytics to monitor equipment health across its global operations. By transitioning from traditional scheduled maintenance to a condition-based approach, GE is able to identify potential issues before they lead to failure. This shift has resulted in more efficient maintenance planning, reduced unplanned downtime, and improved asset reliability. As a result, the company reports annual savings of over $12 million, demonstrating how data-driven strategies can deliver significant financial and operational benefits. How to reverse the domino effect. Stopping the negative domino effect of poor data quality demands targeted action at the structural level, which means prioritizing the systems and processes that ensure their relevance and reliability throughout the asset lifecycle. The following steps form the foundation of an effective reversal strategy. Implement advanced data management systems. Utilize modern data management and analytics tools to ensure data is accurate, accessible, and actionable. Real-time data collection and analysis. Invest in technologies that enable real-time monitoring and analysis of data, allowing for quick, informed decision-making. Regular data audits. Conduct regular audits to identify and address any gaps or inaccuracies in the data so that it remains current and reliable. Prioritize high-value data. Assign business value to data types to guide data quality mitigation efforts toward areas that deliver the greatest operational impact. How small data. Improvements catalyze major gains. Even modest improvements in data quality can unlock meaningful operational and strategic benefits. When maintained consistently, these changes build momentum across the business, including continuous improvement. Regular updates and improvements to data management processes lead to continuous enhancements which accumulate over time and result in substantial long-term benefits. Employee engagement. Training employees on the importance of accurate data and involving them in data management fosters a culture of continuous improvement. Engaged employees are more likely to identify and implement further improvements. Scalability. Across the enterprise. Clean and connected data fosters seamless integration of new technologies such as AI, digital twins, and advanced analytics. With a strong data foundation in place, organizations can more easily adopt these tools and realize their full value across multiple functions. Enabling a safer future. Reliable data is essential to safe and efficient operations. When information is outdated or incomplete, it increases the risk of incidents and adds hidden costs across projects and day-to-day activities. Prioritizing data integrity helps organizations avoid these pitfalls and unlock significant financial value, with billions in potential savings industry-wide. At ReVisionz, we help clients implement scalable data strategies that deliver measurable outcomes. By aligning digital investments with core business capabilities, we reduce costs, improve asset performance, and strengthen compliance. With deep expertise in asset information management and intelligent data insights, we build connected ecosystems where accurate, trusted data drives confident decisions. If your organization is ready to move forward, we're ready to guide you. Get in touch with one of our experts today. Sources. National Commission on the BP Deepwater Horizon. Oil Spill and Offshore Drilling, 2011. About the contributor. Rodrigo Vigna is a senior solution architect with over 20 years of experience in design and information management tools across oil and gas, mining, shipbuilding, and construction. He has worked globally with EPCs and owner-operators to implement technologies that boost efficiency and lower costs. Since joining ReVisionz in 2022, Rodrigo has helped oil and gas clients improve asset information management. Previously at Hexagon, he contributed to developing the SDX platform. He specializes in integrating 3D design systems with documentation, planning, and operations to support safe, efficient, and connected life cycles. With deep technical knowledge in databases, web technologies, and modern APIs, Rodrigo delivers thoughtful, tailored solutions that align with clients' digital strategies.